Hello, welcome to lecture 15 of the game theory class. Uh, if you remember that you learned the Chrono-Nash equilibrium, this is the right class. Uh, Once again, I'm going to review it for you. We studied the dominant equilibrium, which is very nice and all, unique and very strong, accurate credibility, and it accurately predict the future. The only problem is most of the game does not have dominant equilibrium, so it's good only when it exists. However, we want to make prediction for every possible game situation. That's why the John Nash, savior of game theory, came up, and he said there is a concept of Nash equilibrium which says once you begin to play the Nash equilibrium, nobody would change. So nothing will change in out of it. So it's kind of a hole on the ground once you get into that hole of Nash equilibrium, and then it's very tough, maybe not impossible, very tough to get out of there. Okay, it's like everybody driving on the right hand side in Korea. When you drive a car, it's very tough to change that to the left hand side. Okay, people would not even dare to try. Okay, then we have new concept still inside the Nash equilibrium. We dealt with the mixed strategy Nash equilibrium, which is unique because people are not playing just one strategy. They are randomizing over many strategy. And I taught you how to calculate and find out that probability that people randomize over that strategies. As an application of the actually pure strategy Nash equilibrium and the real important cases, we are now dealing with the industrial situations where there is only one company, there is monopoly, where there are infinite number of companies, that is complete competitive market, perfect competition. Okay. And between this perfect competition and monopoly, which you have, I assume, intensively studied in your principles of economics class and microeconomics class, now the most complicated and uncharted territory of duopoly and oligopoly is actually the territory of game theory. Game theory is first specifically made to analyze these situations. And then, even before game theory, there's a two scholar, Kruno and Bertrand, who's mainly interested in this oligopoly and duopoly companies. Are they choosing their quantities or are they choosing their prices? Because they cannot choose both. In the previous lecture 14, we intensively talked about the Kruno competition, where firms are supposed to choose their quantity Q. Now, one more thing, and then we found out the Kruno competition result is turned out to be Nash equilibrium. That's why some people say it Kruno-Nash equilibrium. Now, we have another scholar who think the companies in duopoly and oligopoly situation decides the prices, not the quantities. Okay, that scholar's name is Bertrand, and let's see how Bertrand analyzed the industry, assuming that companies are choosing their prices. In a duopoly situation, oligopoly situation, the firms can compete with their prices and then let the market decide the quantity. If you are a automobile industry and there are two automobile factories, and one firm choose the price 10 million Korean won, the other company, of course, probably he will choose 10 million, maybe different. But anyway, then if both set the price at 10 million Korean won, which is approximately 10,000 US dollar, then the resulting demand, quantity demanded by consumers might be, I don't know, 100,000 cars per year, something like that. Here, the players are the firms, strategies are the prices, PI, which means the price of company I, and the payoffs are the firm's profit pi I. Okay? Okay, we will analyze this situation by dividing the so many cases that may be possible. Okay? We assume that the marginal costs are same. It's constant and same, like marginal cost 1 or 2, something like that. So, and then important assumption is marginal cost 1 equal to marginal cost 2. Without loss of generality, this is a very often used term for mathematician and economist. Without the loss of generality, we'll assume that P1 is less than or equal to P2. You may ask, what? So we are never going to talk about P2 is smaller than P1. P1 is bigger than P2 strictly. But then you don't have to worry about it, because if we prove something when P1 is smaller than P2, then the same logic would apply when P2 is smaller than P1. The company 1, company 2, factory 1, factory 2. I mean, if we change the name, factory 2 can become factory 1, factory 1 became factory 2. So they are identical things. So if we assume that P1 do something, then P2 would do something. Then likewise, if P2 do that thing, P1 will follow. It's like kind of a symmetric. So once we prove something when P1 is smaller than equal to P2, we don't have to worry about proving the same thing when P2 is smaller than equal to P1, because the same proof will apply. So P1 is smaller than P2, and both of them are smaller than marginal cost. One assumption is, not one assumption, the natural assumption is when P1 is strictly smaller than P2, P1 is $1, P2 is $2, the products are identical. Which product are you going to buy? P1, because it's cheaper. The same thing, cheaper, okay? So what if P1 equal to P2? They are same price, then they will divide the consumer half and half. That's the assumption. So P1 is less than or equal to P2. If P1 is smaller, then everybody purchase from company 1. If they are same, half from company 1, half from company 2. What is important is it's smaller than marginal cost. That means the company 1's profit would be less than 0. It's negative if it's smaller than P2. If company 1 has the same price, both pi 1, pi 2 are negative. Can this be on Nash equilibrium? Here, pi 1, pi 2 are the payoffs. So can this be Nash equilibrium? Means the strategy P1, P2 is smaller than MC, marginal cost. Can any of the players change their price and make their payoff bigger? This case, yes. P1, because P1 is smaller, definitely pi 1 is less than 0. If P1, the company 1 sets P1 bigger than MC, what would happen? Everybody will buy from the second company paying P2, and P1 is much bigger than P2, nobody will buy product 1. So pi 1 would be 0. But that is improvement because currently pi 1 is negative. From negative to 0 means the profit has increased. So in this case, company 1 has a way of changing P1 so that his payoff would be improved, which means this cannot be a Nash equilibrium. Same thing here. If P1 is smaller than P2, P2 is same, P1 got negative profit, so he moves over P2, over MC, then his profit changed from negative number to 0 because he's not selling anything. But still, the payoff increases, so this cannot be a Nash equilibrium. Once again, checking whether something is Nash equilibrium or not is, can any of the player change their strategy and make their payoff bigger? And both the first case, second case, they can do that. So it cannot be a Nash equilibrium. Now, P1 is smaller than or equal to MC, P2 is big. Once again, pi 1 can be negative or 0, right? And P2 is 0. Can this be Nash equilibrium? No. Why not? Now, the pi 1 is negative or 0. Let's say P1 is 1, MC is 1, P2 is 2. If you are the first company owner, you will change P1 price slightly over MC, which I assume 1, but smaller than P2. So like 1.5. So you are over your marginal cost, bigger than your price is, P1 is, but it's less than P2. So everybody will purchase from you because P1 is smaller than P2, but still you can make profit because every product you are selling, you have a profit of $0.5. So your profit pi 1 would become negative or 0 to something strictly positive. So naturally, this cannot be a Nash equilibrium. What if P1 and P2 both are bigger than marginal cost? Definitely pi 1 is positive, pi 2 is positive. If they are same. If pi 2 is strictly bigger than P1, pi 2 would be 0. But anyway, what would be happening? If P1 and P2 is bigger, the pi 2 would be 0. Then would you just get 0? No. If it's 10, it's 11, and MC is 1, what would you do? You will reduce the P2 less than P1, which I assume 10, something like 9, still much bigger than marginal cost 1. So pi 2 would be from 0 to something really big positive. What if they are same? They are both 10 and 10, which is bigger than marginal cost 1. Then pi 1, pi 2 are both bigger than 0, positive profit. But P2, the second company would say, oh, if I reduce 9, maybe my profit per product would be reduced from 10 minus 1, 9 to 9 minus 1, 8. So from 9 to 8, it reduced slightly, but everybody who used to purchase the company 1 would be my customer. So the sales would increase more than twice. So P2 would be reduced, or P1 would be reduced. So once again, by changing their pitch strategy, they can increase so they're undercutting the prices and stealing customers from each other. In Korean word, somebody say 가격 파괴. So when the prices are bigger than marginal cost, they are competing each other to reduce their prices. So that means they are keep changing their strategy, which means that cannot be a Nash equilibrium. What if marginal cost is same as price 1, but P2 is bigger? Then the second company has a 0 profit. First company, 0 profit. Different reason. Second company has no customer, no sales, that's why 0. First company has every customer, but whenever he sells, the sales price same as cost, so no profit. So this cannot be an equilibrium, as I said, because the first company, if it's like 10, it's 1, it can increase to 5, still has all the customer, but the pi 1 would change from 0 to something positive. So here the company 1 has incentive to slightly increase the price so that the payoff would be positive. Now finally, what if P1 and P2, the price is the same as marginal cost? Pi 1 would be 0, pi 2 would be 0. Let's check. If P1 increases, what happened? Then the pi 1 would be still 0 because no customer will buy from you. Only P2 that the second company can sell. But anyway, your payoff does not change from 0 to 0. If P1 decreases, wow, then everybody will buy from you. But the more you sell, the bigger your loss would be. Pi 1 would be negative. So in the last case, whether if you increase P, the profit would be same. If you decrease it, your profit would go down. So you cannot make a profit, increase your payoff by changing the price, which is strategy. So the final thing where P1, P2, both prices are same as marginal cost, that would be the Nash equilibrium. So this Bertrand competition where companies are choosing prices, the result is the price will go all the down to the marginal cost. Let's look at review the perfect competition market. In perfect competition market, the price P would be same as marginal cost. So in our example, P equal MC equal 1. And the quantity, because it's P minus 20, P equal 20 minus Q, Q would be 19 when P equal 1. So in perfect competition case, when there are infinite number of companies, the P price would be 1, quantity would be 19, and the profit would be 0. Look at the Bertrand competition. The price would be same as marginal cost 1, and if you put P here, quantity would be 19, and the profit would be 0. Of course, there are two companies here. Therefore, both companies set their price 1. Quantity-wise, company 1 gets 19 over 2, 9.5 customers, company 2, 9.5 customers, but still their profit would be 0. What is interesting is, even though Kruno and Bertrand looked at the same duopoly and oligopoly situation, Bertrand has a conclusion that when you talk about perfect competition, and perfect competition means there should be many companies, just 2 companies is already enough. When you have, so there's a monopoly, but 2 companies, 3 companies, and perfect competition, they are the same, because as soon as you have 2 companies, the price would be same as perfect competition. The quantity would be same as perfect competition. The profit would be same as perfect competition, which is 0. Okay, so if you follow the Bertrand competition philosophy, which means the companies are choosing their prices instead of the quantity. As soon as you have 2 companies in the industry, there are 2 car companies in Korea, then the government don't have to worry about it because they will compete each other, lower their price, and ultimately get the price equal marginal cost, same as perfect competition, which is supposed to be ideal case by Adam Smith. On the other hand, if it's a Kruno competition, as I have explained the previous lecture, the number of companies increase, it approaches perfect competition. So as Kruno competition with 2 firms, 3 firms, 4 firms, what happened? It slowly changes from monopoly market. The price goes down slowly, converging to 1, perfect competition case. The quantity increased slowly, 9.5, 12, 14, ultimately to 19 as the number of companies increases. The profit would be starting from 19.25 and decrease 80, 67 until it hits 0. Okay? So the Bertrand Competition has a conclusion that this monopoly, duopoly, three-company case oligopoly are all different, but it's approaching the perfect competition market. The Bertrand Competition says there's only monopoly market and perfect competition market because two company already we are in the perfect competition business. Okay. So who's right? The economists think it depends on the industry. Let's think about that. You announce that I'm going to choose the price per the Bertrand Competition. So you are making bread every day, and you have Tom's bread shop. Your next door neighbor Bill's bread shop. So Tom and Bill are competing each other to make bread, and they are doing the price competition like Bertrand model, and then you reduce the price over and over, and then originally you started by $10, now it become $2. And when you produce $2, all of a sudden the Bill's customer, like you used to make 100 bread a day at $10 price. Your neighboring Bill's bread used to make 100 bread a day charging $10. Now you reduce your price to $5. Now all Bill's customer come to you 100. So your customer become immediately from 100 to 200. And maybe some extra who didn't eat bread until yesterday, now it gets cheaper. I want to have a bread. So all of a sudden you have 300 customers. You, until yesterday at the price of $10, you produced 100 bread a day. Now you reduce the price at 500 and you have 300 customers. You have to make 300 bread every day. Can you do that? Actually, in many bread shop, increasing the quantity 3 times overnight may not be possible. Okay? Because you have to hire more staff member, you have to purchase more materials like sausages, flours, and milks and things like that. That cannot be done overnight. So you said, oh, I decide the price. I change the price that I'm Bertrand Competition from 10 to 5. So, however, the maximum quantity I can make today is 150, not 300. So even though 300 people come to my shop to buy a bread, I can sell only half of them. Now the question is, you change the price 10 to 5. However, you cannot increase the quantity from 100 to 300. You just 100 to 150. What would be happening? The other 150 customers would go to Bill's because they are disappointed. I want to have this cheap Tom's bread, but he ran out of the supply. So I have to buy from Bill anyway. So then Bill is selling. In Bertrand Competition, people should purchase from the cheaper bread. However, here, even though Bill's price is 10, Tom's price is 5, still some customers has to purchase from Bill because Tom cannot satisfy all the demand. He cannot increase his bread production from 100 to 300. So, is Tom really in the business of Bertrand Competition or in Bertrand Competition? You decide the quantity, but when Tom decide I cannot make any more than 150 today, is he deciding the really price 5 or is he really deciding the quantity 150? It's more like Tom choose the quantity 150, even though he says, I'm choosing the price. Okay? So, in many industry, the capacity is limited. So if the capacity is limited, that kind of automatically means you are in a chrono business because the capacity is the quantity. If there's no capacity limits, you can freely increase the production of bread to 1,000, the next day 0, then you can say you are in a Bertrand competition. So whether an industry, it's not a correct question, is the reality Bertrand or chrono? Some industry which doesn't have this capacity limit, capacity change is free, it's more like Bertrand. In some other industry where in order to increase and decrease, you have to hire people, fire people, you need more machines and things like that, then you are more likely in chrono competition because this capacity limits the quantity. Okay? Finally, I want to talk a little bit about Nash equilibrium. That is, when we are talking about Nash equilibrium, we never talk about how we get there. Okay? I told you before. What Nash said, once you begin to play, nobody would get out of Nash equilibrium. Nash never talked about how we got there. So when you think about Nash, you often confuse. One of the reasons is why they begin to play that. But then that was none of Nash's business, so you shouldn't worry about it. So just checking what if this is this Nash equilibrium means, let's assume everybody begin to play this. Anybody has reason to change. So don't apply your common sense and want to figure out why people beginning to play that Nash equilibrium in the first place. We economists have evolutionary learning gains in order to do that, but haven't been like 100% successful. So that is a good topic, but as long as Nash equilibrium concerned, don't confuse yourself to find out why people begin to play the Nash equilibrium in the first place. Okay, it's normal you are still confused with Nash equilibrium, and that's why we are going to continue this game theory. This is the end of lecture 15, the 5th week of game theory.